All right. We are in grade 10. We are in mathematics, and we are going to be looking at trigonometry as our topic. Now, for this presentation, our subtopic will be right-angled triangles. All right. Let's see. Right-angled triangles. Let me put it here. Is it good here? Yes. Okay. Right-angled triangles. Okay. Now, right angle triangles. Okay. Now, what I want us to look at today, it's simple. We are going to actually look at the right angled triangles. Okay. And I will just draw a right angle triangle here. Okay. It's a triangle that looks like this. It's a triangle that looks roughly like this. All right. It's roughly like this. Okay. And then there is a symbol here which represents 90 degrees. Okay. So when we talk of a right angle triangle, we are talking of a triangle that looks like this. Okay. Now let's go back to trigonometry just to grind down some concepts here. So tri here represents 3. Okay. This part, it represents 3. This one. Okay. 3. Okay. Yes. Now I want to focus on this trigonometry. So gonometry here represents shapes. Gonometry basically is about shapes. All right. Now that means basically here the topic is about a shape with 3 straight sides, or we could say a polygon, 3-sided polygon. Okay, 3-sided polygon. Okay, so when we talk of a polygon, remember we are talking about a closed shape with straight sides. Okay, a closed shape with straight sides. Let's say we have this. Okay, okay, so this shape is closed and the sides are straight, so it's a polygon. Okay, now let's look at a shape like this one. This shape is closed, but now these two sides, this one and this one, are straight sides, but this side is not straight, it's curved. It's curved, this one, so it's not a polygon. Okay, this one is not a polygon, not a polygon. So I just wanted to okay, let me just show you something. Let's say we have this thing here. Is this a polygon? No. Why? Because in as much as it has straight sides, it is not closed. There is an opening here, so it is not a polygon. Okay, this is not a polygon, and this also is not a polygon, but this is a polygon. Okay, it's a 4-sided polygon. Now I was saying a triangle is a 3-sided polygon, so it's a closed shape. Okay, with 3 straight sides. So we have 1, 2, 3 sides. Okay, and all the sides are straight and it is closed. There is no opening anywhere, so it's a polygon. So a triangle, okay, a triangle is a polygon with 3 sides. Okay, Now, let's get into our right-angled triangle. There are different types of triangles. We will look at that when we are dealing with shapes, okay? Now, but now we are focusing on a right-angled triangle. Let me state a few types of triangles. We have isosceles, we have scalene, we have equilateral. You remember those ones, all right? But this one is a right-angled triangle. So in trigonometry, in this presentation, we will focus on this one, right-angled triangle. So why is it a right-angled triangle? It's a right-angled triangle because one of the angles is actually 90 degrees. You can see 90 degrees or this symbol, a square symbol. Okay. Now, let's talk about the tree here, try or three here. So it's all about this. Let's talk about these positions. 1, 2, 3. What are those points? Those are vertices. Okay, they are vertices. Okay, so this is a plural, but a singular would be vertex. A vertex here, a vertex here, a vertex there. So many vertices. All right. Now that means we have in a triangle, we have in this shape, we have 3 vertices. All right. Now, what about this? This, this, and this. What are they? These are angles. Okay? Those are angles. Okay? So that means in this shape we have 3 interior angles. These are angles, but they are interior angles. Okay? There are 3 interior angles. All right? There are 3 interior angles. All right. Now, we talked about this. 1, 2, 3. So those are sides. Okay, those are sides. So we have 3 sides. Okay, now there are 3 vertices, there are 3 angles, there are 3 sides in this shape. So that is why we talk of trigonometry. We are dealing with shapes. We are dealing with shapes with 3 vertices, 3 interior angles, 3 straight sides. Right? Are we clear there? Okay. There is also another element where 3 comes in to describe trigonometry. We have what we call trigonometric, trigonometric. We have trigonometric functions. Okay, we have 3 trigonometric functions. So there are those trigonometric functions. There are also 3. Okay. Now, which ones? We have cosine. It's a function. Okay. We have sine. It's a function. We have tan. It is also a function. Okay. Now, I would say, let me say sine fully and tangent. Okay, so basically the symbols that we use would be cos, would be sine, would be, don't say this is sin. Okay, this is not sin, a biblical term, sin. No, but it's sine. Now this one is tan, symbolically. Okay, so these are the trigonometric functions. Sometimes we say trig functions. We are going to work with these functions on this right angled triangle. Okay, now let's talk about this functions. These functions, there is a tool that I want you to bear in mind that we will use. It's called SOHCAHTOA. This tool, I'm just putting it in advance here. because we are going to use it a lot. Okay, we are going to use this tool a lot. Right, now that I have just briefed you on what we are going to be looking at in this presentation, let's get started. Now let's have our triangle. Let's have our triangle. Let's have our triangle and right angle triangle. All right. Let me say you are given another angle apart from this 90 degrees. This 90 degrees here is just a symbol that should be a flag. That should be as a signal or a flag to you that look, this is a right angle triangle. That's what it tells you. Okay. Now you will usually be given another angle. Let's call it angle theta. Okay. Now this angle is very important also. You are going to discover why I'm saying it's very important. Okay. Now let's focus on the three sides. Now these three sides have names, mathematical names. Now let's look at the names. I will start with the side that is opposite to this angle, 90 degrees. This one, this side. Hmm? Hmm? This side now, okay? This one, this side. The side opposite to 90 degrees is this side, okay? This side is called hypotenuse. Hypotenuse, okay? This side is called hypotenuse. That is its name. Wherever you come across a right angle triangle, note that the side that is opposite to 90 degrees angle, okay, it's called the hypotenuse. That is its name. Everywhere you go, globally, go to Italy, go to Nigeria, go to any continent, they will call it hypotenuse. I think even if you would go to the moon, you will find it as hypotenuse. All right, now let's see now. If you are able to identify the hypotenuse depending on 90 degrees, then the next thing is to identify the side that is opposite to angle theta here. Angle theta here. So that means now you need to identify this side. The side that is opposite to angle theta is always called opposite. Its name is opposite. The opposite side. Okay? Now the third side will be called adjacent. Adjacent. Okay? So these are the three names for the three sides of a right angled triangle. A right angled triangle only. These are the names for the sides of a right angled triangle only. If it's not a right angled triangle, these names are nullified. They don't exist anymore. Okay? Now, let me show you another scenario. Okay? Let me show you another scenario. Woo, God is good all the times. Let's say we have this triangle here. Okay? And we are not given any side. Yeah, we are not given any other angle. Apart from 90 degrees here, we are not given any other angle. How do you name the sides in this case? All right? It is not difficult. It is not difficult. Let's see. What you do is to first of all identify the side that is opposite to 90 degrees. Remember that this sign here stands for 90 degrees, okay? So this side is the hypotenuse. So hypotenuse is this one. Okay? Now, how are you going to distinguish between the adjacent and the opposite? There is no how, because there isn't any other angle theta given. So you just put them arbitrarily, randomly. You can say, I just decided to call this my opposite, and this my adjacent. Okay? Or if you like, you would say, let me call this one my this one my adjacent, and this one my opposite. You have this option only when angle theta is not given. You can either call this opposite or adjacent. If you call this opposite, then that should be adjacent. But if you call this adjacent, then this one should be opposite. All right? But in this case, because you are given angle theta here, this must be an opposite side. Okay? Where there is no theta, this must not. It is not a must that this should be opposite or adjacent. It's not a must. But it is a must when there is angle theta given. That must be opposite. All right. Now let's see. In mathematics, in the practical scenario, you cannot write hypotenuse or adjacent opposite. We use symbols. Okay. So let's say we have this triangle, and it's a right angle triangle. Okay. Now, and then the angle is given here as angle theta. Okay. So the angle theta is given. So what happens next? What happens is this side opposite to 90 degrees is hypotenuse. Okay. So we use capital H as a symbol for hypotenuse. So this side opposite to angle theta given is the opposite. So we use capital O for opposite. So this side must definitely be adjacent. Then we use capital A. All right. So now that means adjacent is basically A symbolically. Hypotenuse is what? Capital H. And then opposite is what? Capital O. Okay? Yes, you need to know that. So you can't always write opposite in words. It's too long. It's too long. It's even expensive. Okay? But you can use O to actually label that side. All right? Okay. Now, let's have a few uh, examples to look at. All right. Let's say you are given this triangle. Okay, and then you are given the angle here. All right. Then you are asked to label the three sides. What do you do? All right, it's easy. This side hypotenuse, this side opposite, then this one adjacent. Okay, that's how you do it. Okay, that's how you do it. Now let's continue. I want to show you something now. After having uh, 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 understood the three sides and how to distinguish them. Okay, now where are we heading? We are heading to their relationship now. How do these sides relate? There is a relationship. That relationship is called Pythagoras theorem. Okay, the Pythagoras theorem. All right. Now, what does this Pythagoras theorem say? What does it say? The Pythagoras theorem is very simple. It is going to relate the three sides. It is going to relate the three sides. So this is O here. Pythagoras. This is O here. Okay? The Pythagoras theorem or the Pythagoras theorem is going to actually relate these three sides of a right angle triangle. So it says that the sum of the squares, the sum of the squares, the sum of the squares of adjacent and opposite is always equal to the square of the hypotenuse. Mm? Mm-mm. So we are saying the square of the hypotenuse side is equal to the square of the opposite side plus the square of the adjacent side, because this is the sum. When we talk of the sum, we talk of addition plus. So the sum of the squares of the opposite side and the adjacent side is always equal to the square of the hypotenuse side. This is the theorem that we need to understand. Okay? This is the theorem that we need to understand. Now, let's get to this theorem now. This one. This one. If h squared equals to o squared plus a squared, then if you want to find h, you will just square root this so that the square root cancels the square, right? And you square root this side to balance your equation. So that means h will be equal to the square root of o squared plus a squared. Okay? What do I mean? Let me say that you have x squared is equal to 4, all right? What do you do if you want to find x? Hmm? You just square root this square root. The square is square rooted so that the square root cancels the square. That's how we remove the square. We remove the square by square rooting. So the rule says if this is an equation, what you do on the left hand side, you must also do on the right hand side. That is why when we square root this left hand side to remove the square, we square root the right hand side to balance our equation. So now our x will be the square root of 4, which is 2. Okay? That's what we do. So this actually it's the basis here. If you want to find the hypotenuse, you will have to square root here h squared so that you get h. Then you square root this side to balance your equation. So h squared, or the hypotenuse side, will be equal to the square root of o squared plus a squared. This is formula number 1 that you need to know from this one. Now, let's say we wanted to find o opposite. What would we do? Let's come to this side. Ta-da-da-ta-da. Like I always say, God is good all the times. So let's say we have h squared equals to o squared plus a squared. All right? So we want to find o. There are how many terms in this formula? There's 1, 2, 3 terms. So we want to find this term. So if we want to find this term, why can't we remove this term? So that on this side we have uh, uh, our o here, o squared. So let's remove this a squared. So once we remove it, once we say minus a on the right hand side, we must say minus a on the left hand side. Remember, this is the left hand side, this is the right hand side of our equal sign. Okay? Now, what you do on the right hand side, you must also do on the left to balance your equation. Okay? Now, a squared minus a squared becomes 0. So what we have here is h squared minus a squared, and then our equal sign. On this side, we are now left with o squared. Okay? But remember, we are not looking for o squared, we are looking for o. That means we need to eliminate this square here. How do we eliminate the square? How do we eliminate the square? Ta-da! This is how we eliminated the square. We just square root. Now, that means we are going to square root here. We are going to square root here. Here. We square root so that the square root cancels the square here. We square root on this side to balance our equation. So what does that mean? That means ultimately we are going to have o, or we are going to have the square root of h squared minus a squared is equal to O. And O is the opposite side. So that means if you are asked to find the opposite side, you will use the formula opposite equals to the square root of h squared minus a squared. That would be the second formula for your own benefit. All right? Can you make adjacent side the subject from here? Can you make adjacent side the subject from here? What would you do? You would do this. You would say minus O squared because you want to be left with A squared. Minus O squared minus O squared. That means on this side you are going to have h squared minus O squared equals to A squared. Okay? Next, we remove the square by square rooting. The square root cancels the square. We square root this side to balance. Okay? So we are going to identify this A as h squared minus O squared. That would be our adjacent. Okay? So now, what does that mean? That means adjacent is equal to the square root of h squared minus O squared. That would be the third formula that will help you in this topic. So, in a nutshell, you can be given two sides of a right angle triangle and be asked to find the third side. Oh, I've got you now. All right? You can be given two sides. Let's say you are given the adjacent side and you are given the hypotenuse side. You are asked to find this, the opposite side. So, how would you do that? You would just say, okay, from my list of formulae, this one, which has to do with the three sides of a right angle triangle being the hypotenuse, the opposite, and the adjacent. From this content here, you can be able to find the opposite side, which is this one. You would say opposite equals to the square root of hypotenuse squared minus adjacent squared. Then you say equals the square root of hypotenuse will be given, you put that value and you square it, minus the adjacent will be given as a value, you put the value and square it and work it out, you will find the opposite. That's, my friend, will be covered in our next presentation, which will be trigonometry part 2. That's why we are going to be looking at examples whereby you are given two sides of a right angle triangle and you are asked to find the third side. Take care.